Organic chemistry nomenclature is the naming of the hydrocarbon compounds studied in organic chemistry. The naming is based on a system of prefixes and suffixes that all give meaning to the structure of the compounds. To begin, it's important to know the prefixes that indicate the number of carbons in the compound. Here are the first 10. 1 through 4 are rather uncommon, so those are the hardest to memorize. The prefix meth refers to 1 carbon. Eth, 2 carbons. Prop, 3 carbons. And bute, 4 carbons. The endings of the words, names of these hydrocarbons, indicate the bonding between the carbons. Those compounds ending in ane, A-N-E, all have single bonds. If it ends in ene, E-N-E, there's a double bond. And if it ends in ine, Y-N-E, there's a triple bond. Here are the first few examples. Under the alkanes, methane with 1 carbon and 4 hydrogen is shown in a stem structure with carbon at the center surrounded by hydrogens. Carbon can have 4 bonds. Therefore, 1 carbon will be bonded to 4 hydrogens. Ethane, on the other hand, has 2 carbons, so some of the bonding is used in the carbon-carbon bond, reducing the total number of hydrogens available to bond to complete the 4 bonds for each carbon. You can see that propane and butane are similar, except that they are extended strands with single bonds between the carbons and then hydrogens surrounding. For the double bonded alkenes and triple bonded alkynes, the additional bonds between carbons reduce the number of hydrogens available. Where ethane has a formula of C2H6, ethine has a formula of C2H2. Notice that in every instance, each carbon has exactly 4 bonds. When the hydrocarbon bonds in a circle or a ring, these are referred to as the cycloalkanes. Here are 4 of the more popular cycloalkanes that we've discussed in class. Cyclopropane has 3 carbons, just as propane has 3 carbons, only they're wrapped into a ring. Cyclobutane has 4 carbons because of the prefix bute, and is wrapped in a circle because of the prefix cyclo, and so on. Substances that contain the hydroxyl group, OH, are alcohols. These structures are named based on the number of carbons in the compound and have the suffix of OL to indicate the presence of the OH group on the molecule. Methanol, therefore, is methane, where 1 hydrogen is substituted with an OH group. Butanol, a strand of 4 carbons, has 1 hydrogen removed for the OH group. Likewise with octanol. Hydrocarbons with substituted alkyl groups have a naming system that's a little more involved. First, you have to identify the parent strand. In this case, it would be the string of 6 carbons. 6 carbons with single bonding will be referred to as hexane. On this particular model of hexane, there is a methyl group as well as a halogen bromine. To add those components to the name, we have to consider them alphabetically. Bro comes before meth. The number of the carbon that it's attached to becomes part of the name. In this case, the bromine is located on the 2nd carbon, so it would be called 2-bromo, 4-methyl hexane, because the methyl group is located on the 4th carbon. There are more complex variations, but the basic rules remain the same.